In this video, we're going to continue our work with solving equations. And today we're going to up the ante just a little bit and add a couple of steps. So to get started, I'd like to have you pause the video and solve this question very quickly. And then we're going to spend some time discussing alternative ways to approach this question and why. All right, so the traditional way we would solve this question would be simply to add 6 to both sides. And that would give us 2x equals 16. And then we would multiply by a half or divide by 2, because a half of 2 cancels out the 2, and I get x equals 8. And that is the answer. But I'd like to analyze this just a little bit real quick, because what it looks like I've done to some people is not really what I have done. So let me start with this. It looks like we've just added 6 to negative 6, right? Because I wrote the 6 under the negative 6 and it canceled out and everything was great. And in reality, that's how it's done. But that's not really what I've done to solve this problem. So I'm going to take another stab at it, and I'm going to do it right here. So I'm going to rewrite this problem. I'm going to give myself just a little bit of room here. Okay, so when we solve this problem and it looks like we add 6 to the negative 6, what we're really doing is we're adding 6 to the entire left side of the problem. So I'm going to write this out kind of in a more inefficient way. But what I'm really doing is I'm saying, okay, on the left side of my scale is this 2x minus 6 thing. And I am going to add 6 to the entire left side of this problem. So I've changed the scale, right? It's now heavier. And so to balance it out, I'm going to have to add 6 to this side. All right, so now I just need to simplify the left side of the problem. Well, the parentheses I added aren't really doing anything. They're just there to sort of separate, like, hey, this is the thing that was over here on the left side. So they're not really doing anything. And so I'm just going to rewrite this now as 2x minus 6 plus 6 equals, and we can go ahead and add those together. Now, when I look at this, now I have this problem where I have multiple things going on the left side over here. But order of operations and how we combine like terms is important. So how do we add things together? Remembering I'm adding 6 to this entire thing. But how do we do that? We can only add like things together. So that means the minus 6 and the plus 6 combine together and cancel out to be 2x plus 0 equals 16. And then 2x plus 0, of course, is 2x. And so I get down to where we were, right here at this step. So the point I'm trying to make is, while it looks like all we did was add 6 to negative 6 and didn't add it to the entire side, what we really did was we added it to the whole side. It's just the way that addition works. We only combine like terms. So we never added this 6 like to the 2x because you can't do it. We add the 6 to what you can add it to. All right. So that's going to be a key piece moving forward about why it looks maybe different than what I'm about to show you. All right. So the question I'm going to now give you is, do we have to do the addition piece first, or could we possibly deal with the multiplication piece? And the answer is, yeah, we can do this a different way. You don't have to. This is again for those students who've got everything figured out and need a little bit of extra thinking. So let's start again. Let's go back to 2x minus 6 equals 10. Now, if you want to, you could start by getting rid of the 2 first. And the general rule of thumb would be we have to, whatever we do to one side of an equation, we do to both sides. But the key word there is the word side. In other words, the whole side. So if you, for whatever reason, want to show off and want to be like, hey, I can do this a different way, cool. Let's make sure we do it the right way. So if you want to deal with this too, we do not just divide this term by 2. Just like up here, we didn't add 6 just to the 6, the minus 6. We added the 6 to the whole side. So if you want to multiply the whole side by a half, or divide, you have to do the whole side, which would either make it look like times a half right here, or I suppose if you really are wanting to do division instead of multiplication, then you're talking about dividing the entire side by 2. And then what we do to one side, right, we have to do to the other side. So I'd multiply this side by a half as well, and I would, maybe divide this by 2 if you're doing the division method. Okay, now order of operations says if I want to simplify this left side, I have to do the distributive property. So I do 1/2 times the 2 and the 1/2 times the -6. So that gives me x minus 3 equals, and then half of 10 is 5. If I'm looking at it the division method, then it's not obviously a distribution property question, but really it is, because this 2, we're telling you divide this first term by 2 and the second term by 2. So 2 divided by 2 is 1x, minus 6 divided by 2 is 3, and we are at the same place. And then, obviously, there's only one thing left to do. We're going to add 3 to both sides, and I get x equals 8. Okay? Now, again, what did we do in this problem? If we want to divide first, while there's still 2 terms, what we have to understand is that we're dividing or multiplying by half both of the terms. You aren't just dividing the 2x. You're not just multiplying a half by the 2x. It's everything. It's the entire side. So that is why we generally talk about let's deal with the adding and subtracting first, because then when we move it over, now I've only got one thing on the side, and so now I'm just doing half of 2 because there's nothing else there. But if I still had more terms here, I would be doing it to both terms, or all 10 terms, or however many are there. Okay, so for those of you ready for such things, there are times when it's going to be easier to do the division or multiplying by the reciprocal first, and there are times when it won't be. It's just, if you're going to do something, just make sure you do it the right way. All right, hopefully that made sense. If not, we can talk it through more in class. So let's get to what we're going to be working on today and see if anything I just said will come into play. So solving equations, this time we're going to be looking at, if you'll notice, there's a little more going on each of these problems. So we're just upping the stakes a little bit. But in general, and again, just like everything, there are other ways of approaching it. But the way we're going to be talking about it in class is we want to simplify each side of the equation first in almost every circumstance. All right, so we look at a problem like part A. And again, focus is the issue. It's not about the math being hard. It's about paying attention to the details and then following through. So what I want you to notice, and you don't have to do this in your paper. In fact, I kind of prefer you didn't, but just visualize the fact that we've got 2 sides of the equal sign. And you'll notice on the left side, there's some math we can do. Like we can actually do 4x minus 10x. I'm not talking about moving things to the other side. I'm not talking about doing opposite operations. I'm just saying this problem says 4x minus 10x. And I can do that math, so let's do that math. So 4 minus 10 is -6. So I am going to simplify the left side to negative 6x, plus 12. And I'm going to get rid of this dotted line now because it's getting in my way and it's annoying me, equals 48. So sticking with the traditional way of solving this, although you can play around with it if you want, now it's just like what we did yesterday. So the first thing you want to do is simplify whatever can be simplified. And now, since I can't add these 2 together, they're different terms, there's nothing else to simplify on this side. So now it's just about getting x by itself. So adding 12, the opposite is to subtract 12. Bring down that negative. Don't lose sight of that negative. As soon as I spotted this 4 minus 6 minus 10 was a negative, I'm just going to keep in, like that's in my mind the whole time. I'm not going to lose sight of it. 48 minus 12 is just going to be 36. And then I'm going to either, again, I'm kind of loosening the reins a little bit. You can either write this as a divided by -6, which is the easier way to show it. Make sure it's negative divided by a negative. not just a positive 6. And so that cancels out, and I'm left with x equals 36 divided by 6 is 6, and it's going to be a negative since I have one negative. And that should be my answer. And I can go back and plug it in and check it and make sure I got it right. And then you know if you're on the right track. All right, let's look at part B. Part B, you have options. The traditional, hey, like let's keep you from getting too confused. The traditional way of solving this would be just to apply what we see on the left side, right? There's math to be done over here. So before we're worrying about moving things to the other side, we go ahead and do the math that we see. So I can do a distributive property right here and do 2 times 1 and 2 times 8. So that's going to give me 2 plus 16k equals 82. Stop and analyze. I can't add 2 and 16 together because that's a k, and so there's nothing else I can do. So now it's about solving. So let's move the 2 out of here because we usually start with the add and subtract. And I get 16k equals 80. Once again, you can multiply by 1/16, or you can just divide by 16. I'll mix it up on us. This time I'm using the multiply by reciprocal idea. That gives me 80 over 16. Now, 80 over 16, for those of you who have forgotten how to reduce fractions or just need a quick refresher, I would start with noticing that that's 8 times 10 and 8 times 2, right? 80 is 8 times 10, 16 is 8 times 2, so my 8s can cancel. Well, that leaves me with 10 over 2. And again, what does that mean? That means 2 times 5 over 2 times 1. They both have a 2 in them, so the 2's can cancel. X equals 5. That's how we reduce fractions. All right. Okay, let's look at part C. And be very careful here. Once again, spot each side of the equation, and we see that we have a lot going on the right side. And so we should simplify. Well, to simplify, we're not going to do negative 4 plus 4 because that's an addition question. And this, of course, is multiplication. And we know we have to multiply first. So this problem, if we're paying attention, is negative 4 and then distribute. 4 times negative 4 is going to be minus 16n. Positive 4 times negative 1. A positive and negative makes it negative, and I get 4. Now, there's some math we can do on the right side before we start worrying about solving. I have a negative 4 minus 4. So I have negative 72 equals negative 8 minus 16n. I got to get rid of this minus 8, so I'm going to add it on both sides. And I'm going to get obviously a negative number, and then I just need to do 72 minus 8, which is going to be 64. So it's negative 64. Again, I spotted right away all these negatives in the problem, and so I'm focusing on them. I'm paying attention to them. It's not an accident I get them right. It's because I'm paying very close attention to them. And if I get them wrong, it's because I've stopped paying attention. All right, my 8s are gone, but this negative right here, still paying attention to it, that's still part of the 16. So now I have negative 16n. Still paying attention to the negatives. I know I need to divide by negatives or 16, but I need to make sure I do a negative 16 because I don't want this negative left behind. I want it to be gone because I only want positive n. Negative divided by a negative is a positive. Negative divided by a negative is a positive. And then I get 64 divided by 16, which I believe is 4. Why do I think it's 4? Because I'm looking over here at 64 over 16, and I'm thinking about 8 times 8 over 8 times 2. My 8's cancel, and I'm left with 8 over 2, which is 4. All right, I want to stress to those of you who are like itching to be more creative and like try things a little differently, there are other ways of approaching these problems. Just make sure you follow that whole idea about what you do to one side of an equation, you do to both. But if you're like, you know what, I don't need to be creative, I'm just going to stick with the tried and true method, then that's what we're doing here. Once again, we're going to start by analyzing, and I see I have work I could do on the right side. So I'm going to do that work. I'm also spotting all these negatives, and I'm paying attention to them. A negative times a positive when I do the distributive property makes negative 16x. Negative times a negative is a positive. I've got 4. I now am going to deal with the 4. And I'm left with, looks like negative 64. Because they're both negative, so they add together. And now I'm going to divide by negative 16. Which, if I'm not mistaken, we just did that problem a second ago. Or maybe we didn't. Yep, 64 divided by 16 was what we did on the last problem. And so I know the answer is going to be x equals 4. By the way, I have no problems. In fact, it kind of hurts my soul a little bit to write it like this. So we've answered this question, x equals 4. If you, even though it shows the x on the right side, like it doesn't matter what side things are, you can flop the sides at any point. So if you want to write this as x equals 4, even though it says 4 equals x, they're obviously the same thing. All right, let's pick this up a little bit and shorten this video. 11x plus 5x, we can actually do that math. And that gives me 16x equals 48. And now I'm just going to divide or multiply by the reciprocal. I'll show division this time. And I get x equals 48/16, which is going to be 3, I believe. And if you're not sure, we just got to approach it. 48 is 8 times 6. 16 is 8 times 2. So the 8's cancel. 6 divided by 2 is 3. All right. And here we have an interesting problem. First of all, for those of us who are kind of more on the advanced side of things, what I want you to realize is this problem, written as it is, could also be written not as a divided by 4, but as a, now I'm not suggesting we do this, but I want you to know that these two problems are 100% the same. Because that's what this is saying. There's an implied parentheses right here that we're doing the entire top divided by 4, right? Or doing the entire top times a fourth. They're the same thing. Now, does one help you over the other? Not necessarily. We just need to recognize and understand that this divided by 4 applies to the entire side. So, what are we going to do? I could go ahead and follow the rules I said, which is simplify each side first. But that kind of makes a mess, and let me show you the mess. If I go ahead and divide the side by 4, I'm going to get x over 4 plus 6 over 4, and 6 over 4 can reduce to 3/2. So I've taken a problem and I've introduced a fraction. Now the next thing I would have to do is subtract 3/2 from 5, and this problem's becoming less fun by the moment. So the other approach would be, let's take a look over at what I've written on this side. If I were to instead decide, you know what, this 1/4 is ticking me off and I don't like it and I want it to go away, what I can do is I could multiply the entire side, right? Because what you do to one whole side, it has to be the whole side. I'm going to multiply this side by 4. And why 4? Because multiplying by a fourth, to undo multiplying by a fourth, we multiply by the reciprocal. The reciprocal of 1/4 is 4. So now I have a problem that looks like I'm doing a 4 times a 1/4 times an x plus 6. And now what I want you to notice is I have 2 multiplication questions. And we know we multiply from left to right. So the first thing I would do is go 4 times 1/4, which is just 1. So in other words, by multiplying the entire side by 4, I cancel out that 1/4 before I even have the opportunity to do a distributive property. And now things look much better. Okay, so let me erase all this and start over and make it a little bit cleaner for us. So whether or not we approach it just as a division problem like this one, or I rewrite it or rethink it, you don't have to necessarily rewrite it if you just seed it this way, then what I can tell is, you know what, if I were just to multiply this side by 4, this 4 on top is going to cancel that 4 on the bottom. And so I get x plus 6 equals 20. Or I come over here and I say, you know what, if I multiply by 4 on both sides, then 4, it's all again left to right. 4 times a fourth is 1, and I'm left with x plus 6. Multiply this side by 4 also, and I get 20. So by doing it this way, I'm avoiding that nasty fraction that I was about to create. And now I just subtract 6, and of course the answer is 14. And I promise you that's going to be a much better way to get 14 than what would have happened had we divided first. All right, so try G on your own. Make sure you visualize what this problem is really saying, but you do not have to rewrite it and get that answer. All right, so I'm seeing this problem like this. That's what it really says. I'm not changing the problem. That just means the same thing. Why do these mean the same thing? Because if I were to multiply, this is a 1 over 3 times a 2a minus 5 over 1. So we multiply straight across, and it gives me the 2a minus 5 on top and 3 minus 1 on the bottom. So that's why these are exactly the same. All right, so that means multiplying by 3 to start, either here or here, is the way to go. Looking at it this way, we have this 3 on top, cancels out that 3 on the bottom, and I'm left with 2a minus 5 equals negative 27. Or if you prefer looking at it as a fraction, 3 times a third is 1, and then distributing the 1 does nothing, of course. And either way, we're in the same spot. Now it's a simple two-step equation. We're going to add 5 to both sides. I'm spotting the negative. I'm not going to make a mistake. 27 minus 5 is 22, so it's negative 22. And now I'm going to divide by 2 or multiply by half. And I get a equals negative 11. Maybe worth checking our work on this one since there's a lot going on. Let's see what happens. I'm going to plug in negative 11. Gives me negative 22 minus 5 is negative 27. Divided by a positive 3 should be negative 9. And that's what we started with. So that's the correct answer. Okay, so let's recap real quick. When you're faced with a problem and there's math to simplify on one side, simplify first. So the x's got added together, and then we moved the 12. All right, here was a distributive property, so we did the distributive property first, and then we combined like terms. But in some cases, as we showed down on F and G, simplifying the left side, which would have been dividing x by 4 and 6 by 4, would have led to kind of a headache. So here we're kind of breaking our rules, and we're not simplifying first. We're actually getting rid of this 4 first. So rules are meant to be followed up until a point where they make things too difficult, and then we find a few little loopholes to get around them. All right, I hope all this makes sense. If not, please make sure you spend some time talking to me about it, and let's get you all caught up.